Alright, this lesson is all about the relationship between the parts of segments that are inside of circles or stretching outside of circles like these in certain cases. The bottom line is there are two new formulas that you need to familiarize yourself with. And this one is the one that you run into when you have two chords that are intersecting, and so that creates these four segments if you look at it in pieces. And what you find is if you look at one segment at a time, one chord at a time, part times part of one segment will equal part times part of the other segment. So for example, por ejemplo, if you were to look at, let's see, if you were to look at this chord first, all right, the parts are D and K, so we would say D times K equals, and then the two parts of the green chord are R and M, so R times M. D times K equals R times M. Part times part equals part times part. So that's what we are dealing with when we look at problem number one. So for problem number one, part times part would be 23 times x, which we can just write 23x, and that should equal part times part, which will be another 23 times 15. So 23x will equal 345. And then it will be time to divide both sides by 23. And x is equal to 15. Oh, for number two, part times part, we could do 6 times x, or 6x, is equal to part times part. So that's 3 times 4. Okay, so 6x is equal to 12. Of course, we would divide both sides by 6. And that will give us x equals 2. Alright, problem number 3 gets slightly more complicated. Part times part, so I could do x times 12, which is 12x, but that equals part times part. That equals 6 times x plus 4. Alright, that is a plus in there, it's hard to see. So we have x's on both sides is all, so that's going to give us 12x is equal to 6x plus 24. If I subtract 6x from both sides, that leaves me 6x equals 24. And we will divide both sides by 6. And that will give us x equals 4. Alright, so it wasn't too complicated after all. Okay, looking at chord DE. Alright, let's see, I'm trying to make sure I'm getting these right. So part times part, that's x and 12. Alright, so that will be 12x. And that should equal part times part. That's another plus in here, it's a little hard to see, but part times part, so that's 6 times x plus 5. So that's 12x equals, and we're doing the distributive property, so 6x plus 30. Subtract the 6x from both sides, and you'll get 6x equals 30. Then you divide both sides by 6. And you get x equals 5. And that's the answer to number 4. Okay, looking at segment DE, I believe that these are the parts of chord DE. Okay, so part times part is looking like x times x plus 13. And equals part times part. And that looks like x plus 10 times x plus 1. Alright, I'm putting it up high for a minute so I have a little space. We need to double distribute right here. Alright, x times x is x squared. X times 1 is x. 10 times x is 10x. And 10 times 1 is 10. And over here, I've just got x squared plus 13x. So combining like terms right here gives us x squared plus 13x is equal to x squared plus 11x plus 10. Subtracting x squared from both sides cancels out both x squared. So that's going to leave me with 13x is equal to 11x plus 10. I see x's on both sides next, so I will subtract 11x from both sides. Okay, so that's going to leave me with 2x is equal to 10. And it's time to divide both sides by 2. And x equals 5. Okay, part times part equals part times part. Alright, so x times x minus 6, alright, that's part times part, equals x minus 10 times x plus 12. So a little distributive property here gives us x squared minus 6x. Double distributive property here. So x times x gives us x squared. X times 12 is 12x. Negative 10 times x is negative 10x. And negative 10 times 12 is negative 120. Alright, combining like terms right here, so that's going to be, so I've got x squared minus 6x equals x squared plus 2x, alright, I'm just combining these two, minus 120. That's an awful big number. Subtracting x squared from both sides, both of those cancel out, so now I have negative 6x, whoops, not plus, negative 6x equals 2x minus 120. I will now subtract 2x from both sides. So negative 8x equals negative 120. Divide both sides by negative 8, and you get x equals positive 15. So that is your answer to number 6. Alright, now with number 7 we need to introduce a new formula, because notice how this time the segments are coming outside of the circle. When that happens, this is the formula that we are working with. Part times whole equals part times whole. Now when I say part times whole, it has to be the external segment times the whole secant. So again, looking at this lower secant segment, it's got to be the external part times the whole thing. D times K equals R times M. Part times whole equals part times whole. Okay, so for instance, looking at the top segment, the part has to be the outside part. So 3 is the part. So when I say part times whole, alright, so this is what I'm saying. I'm saying part times whole equals part times whole, okay? 3 is the part, and the whole is x plus 3. Okay, the whole is the sum of the two parts, so x plus 3. Now when I look at this lower segment down here, the part is the 2, alright, because it must be the external part. So that's the part. The whole is 12, 10 plus 2. So this is what we need to solve. So distributive property, this will be 3x plus 9 equals 24. Subtracting 9 from both sides, you get 3x equals 15 divided by 3. So guess what? That is x equals 5. So that's the answer to number 7. Okay, looking at these two, the 4 is the part, because it has to be the outer part. So I put that first. The whole is the sum of these, so x plus 4. So remember, we're doing part times whole equals part times whole. Again, the part has to be the outer part, the 5, not the 3. And then, of course, the whole is the sum. So distributing gives me 4x plus 16 is equal to 40. Go ahead and subtract 16 from both sides. And that will give you 4x equals 24. And we divide both sides by 4. So we get x equals 6. That was the answer to number 8. Alright, number 9. Part times whole. Alright, 5 is the part because it has to be the outer part. The whole is the sum of these. I'm going to say x plus 5, but you could say 5 plus x if it makes you happy. And looking at the upper segment, part times whole, 6 is the part. It has to be the outer part, times the whole, which is 10. So part times whole equals part times whole. So distributive property tells me that 5x plus 25 is equal to 60. Subtract 25 from both sides. And that gives me 5x equals 35. And then we divide both sides by 5. And x equals 7. And that was the answer to number 9. Alright, looking at number 10, part times whole. It's a little tricky, but the part is definitely the 8 because that's the part that's out there by itself. The whole is the sum of all of this, okay? Please understand that the whole is the x plus 3 part that's right here plus the 8. Alright, it's this plus this. Okay, that's the whole. And we'll simplify this later. Now, meanwhile, here we have part times whole. So, again, 10 definitely has to be the part. Okay, but the whole is 10 and x minus 3. So the whole is x minus 3, x minus 3 plus 10. Alright, it's this plus that. So that was a little tricky to understand. Might have to pause the video, go back and look again. Part times whole, the sum. Anyway, to simplify these, the little brackets are just a grouping symbol. They're not really changing anything. So the 3 and the 8 make 11. So this is x plus 11 in here. The negative 3 and the 10 make 7. And then you can go on and do the normal distributive property. So I get 8x plus 88 is equal to 10x plus 70. I like to get the x's together as soon as possible. So I am going to subtract 10x from both sides. Alright, that is going to give me negative 2x plus 88 is equal to 70. Subtract 88 from both sides, so negative 2x is equal to negative 18. And then we divide both sides by negative 2, which of course will give us x equals 9. And that was the answer to number 10. Okay, this one's a little bit of a special case. No, it's not. Never mind. So part time, I thought it was a tangent for a second, but it's not. I see the 27 and the x. Anyway, part times whole. The part is definitely the 21 for that segment, secant segment. So the part is 21. The whole is the sum of these two. Okay, I wonder if you'll let me do this mentally, you know, add these two together. So if I add these two together, I'll definitely have the 2x, so that's not going anywhere. But then I've got 21 and 8. Those are the like terms here. So that's going to be 29. So 2x plus 29. Okay, so I did part and then I did times whole. So that's that. And then I will set that equal to. Now between the 27 and the x, 27 is definitely the part because it's that outer part that we need. And then the whole is once again x plus 27. It's the sum of these. Okay. Distributive property with a couple big numbers. So this will be 42x plus 609 is equal to 27x plus 729. Next we will subtract 27x from both sides. I feel like I'm about to fall asleep, you guys, in the middle of a problem. So that's going to give us 15x plus 609 is equal to 729. Subtract 609 from both sides. And I have 15x equals 120. Okay, and then I will divide both sides by 15. So x equals 8. And that's the answer for number 11. Number 12, we're using the formula part times whole equals part times whole. 15 is the part for the upper segment, so I will do 15 times. And the whole is 3x plus 15. Alright, so this plus this. Now, between the x and the 20, 20 is the part, and the whole is x plus 20. So, part times whole equals part times whole. The part is always the outer part. A little distributive property here gives us 45x plus 225. Alright, that 20 will distribute, so that'll be 20x plus 400. Alright, now it's time to get the x's together, so I will subtract the 20 from both sides. And this is going to give me 25x plus 225 is equal to 400. I would subtract 225 from both sides. So I will get 25x is equal to 175. And then of course we will divide both sides by 25. 7. And that is our answer to number 12. Alright, look, for number 13, we're still doing part times whole because it's still poking outside of the circle. And the outer part still has to be the part when I say part times whole. So part times whole, using the lower two numbers first, would be 5, that's the part, times the whole thing, which is x plus 5. Now that should equal part times whole. Well, 10 is the part because it's this external part, but 10 is also the whole. It's the whole thing. There's nothing else. So it would be more efficient to write 10 squared instead of 10 times 10. So distributing, that will give us 5x plus 25 is equal to 100. And then you subtract 25 from both sides. So that gives you 5x equals 75. And then you divide by 5. X equals 15. And that is the answer to number 13. Alright, similarly on number 14, might as well start with this one. The x is the part and the whole. So part times whole would be like x times x, and you might as well just write x squared. Now here I'm doing part times whole. 9 is the part. The whole is 9 plus 7, so that's 16. Alright, so I've got x squared equals whatever that is. 144. How do we unsquare things, you ask? Well, we take the square root. And that gives us x equals 12. Number 15. Part times whole. 9 has to be the part. So let's start with that. And the whole is 4x plus 9. So 9 times 4x plus 9. We're doing part times whole equals part times whole. When we say part, it has to be the outer part. Now 15 is the outer part, and 15 is the whole thing. There's nothing else going on. So that's going to be, with a little distributive property, 36x plus 81. 15 times 15 is 225. Subtract 81 from both sides, and we have 36x equals 144. Dividing both sides by 36, x equals 4. And that was the answer to number 15. Alright, number 16. I don't know if you guys can tell, but I was falling asleep there. But I did some exercises. I'm feeling pumped. I think I can make it through 3 more problems. These problems look a little weird because where's the variable, right? But they say find PQ. So guess what? You can make your own variable. See how easy that was? Just put an x. So let's do our thing. Part times whole with the PQ. Again, x is the part and the whole. So part times whole is x times x. You can just go ahead and write x squared. I'm just breaking it down. Then down here, part times whole. 12 has to be the part, not the 15. It has to be the outer part when I say part. And the whole is whatever 15 plus 12 is, 27. Okay, so we got x squared is equal to 324. Now I've got to take the square root of both sides. When I'm sleepy, I make so many mistakes. I wonder how many mistakes I've made in this video so far. X equals 18. Alright, I'm sure Trey will be posting me soon if I made any mistakes. Wait, Trey's not in this class. That's advanced algebra. Never mind. Okay, number 17. We're still supposed to find PQ. Those are the directions for the whole thing. So, finding PQ, make your own X. Okay, DIY. So, part times whole. Which one of these is the part, people? That's right, 24 is the part. It's got to be the outer part is the part. The whole is X plus 24. Okay, now the other segment, 36 is the part and the whole, so it's 36 times 36, or 36 squared. These are big numbers any way you slice it. So I've got 24x plus 576 is equal to 1,296. Subtract 576 from both sides, and that's going to give us 24x is equal to 720. Then we go ahead and divide 24 on both sides, and we get x equals 30. And that is the answer for number 17. Alright, number 18. Once again, we are supposed to find the length of PQ. So you just put your own X. So that's PQ. So, part times whole. Which one of these is the part? It's the X, because it's got to be the outer part is the part. So part times whole, that's X times X plus 48. Okay, part times whole is equal to part times whole. Well, that's 70, because it's a tangent. 70 is the part and the whole, so you have to do it twice. So distributing, this is going to give me x squared plus 48x is equal to 4,900. I have x squared and x, so I'm going to have to either factor or use the quadratic formula. Either way, I need 0 on one side, so I'm definitely going to subtract 4,900 from both sides. So I've got x squared plus 48x minus 4,900 is equal to 0. Well, with a number that big, I'm really liking the idea of using the quadratic formula. So that is what I'm going to do, my friends. Remember, the quadratic formula looks like this. It goes x equals opposite of b plus or minus square root b squared minus 4ac all over 2a. We like to do the discriminant first. That's the b squared minus 4ac part. So that's what I'm going to do. That's what we do around these parts. So b squared minus 4ac, I'll just put a little arrow here. Of course, a is 1, and b is 48, and c is negative 4,900. So b squared is 48 squared, alright, minus 4 times 1, which you didn't really need to write that, times negative 4,900. Alright, this is the discriminant. That is 21,904. Man, that's a big number. So now we can go ahead and do the quadratic formula. So x is equal to the opposite of b, so that's negative 48 plus or minus the square root, and we already did the b squared minus 4ac, so we can just put 21,904 in there, all over 2a. Well, 2 times 1 is just 2. Okay, let's see what the square root of 21,904 is. Turns out that is 148. Alright, it's a whole number. So that's going to give us x equals negative 48 plus or minus 148 over 2. Okay, and we're going to turn this into two answers by doing negative 48 plus 148 over 2 and negative 48 minus 148 over 2. That's the plus or minus option. Alright, this one gives me 50, and this one gives me negative 98. Now, only one of these makes sense in this context because we're talking about the length of a segment, and a segment cannot have a negative length. So this one is what you would call extraneous. Okay, that means it is undefined in the context of this problem. You can't use it. So the only answer is actually 50. PQ is 50. That's it. Alright, and so that was the answer to number 18. And that is the end of this lesson. I hope it was helpful. I will see you on the next video.